All right, so in the second module, we're going to talk about electron configurations. And so this is taking that basic information we just learned about atomic structure and looking specifically at the electrons. Okay, so we still kind of view electrons by those discrete energy levels that we just talked about. And if we plot the energy of those various levels, so you see here that we get the principal quantum number, so the shell, 1, 2, 3, 4, and so forth. And then the S, SP, SPD, SPDF, all of those refer to the subshell, so that second quantum number L. So those are just 1, the principal quantum number, and then the subshell is S, which refers to 1 as well. So the S, basically these lowercase numbers also refer to numbers of that second quantum number, the azimuthal or subshell. So the ones with the lower numbers, such as 1 here, tend to have lower energy. And then as you go up, the energy goes up because this y-axis is energy. And then same thing with the second number, L. So S tends to be the lowest, P tends to be the next one, D, and so forth. That tends to be the general order. However, you do see some cases where, for example, the 3D is slightly higher than the 4S. So there are some cases here where there's overlap, or where there's very similar, or where the one with the lower numbers doesn't necessarily have the lowest energy. So there's some overlaps that we see here as you look through this graph. All right, so if we're thinking about a given element on the periodic table, and we want to be able to describe the electrons in that element, we have this scheme for figuring out the electron filling sequence, starting with the lowest number atomic number element to the highest. And we can use this schematic here to do this. So the way this kind of is drawn out is that we fill the lowest first, so 1s, and then we follow the arrows. So after the 1s, so if you fill 1 electron, and then again for each subshell, for each orbital, you would have 2 electrons. So this an s would have 2 electrons, and so after you fill 2 electrons, you would go to the next. So you'd follow the arrow down, and there's nothing there. So you'd basically come back up and catch the next arrow, and so that would be the 2s. And all of these s hold 2 electrons. And so you'd fill that first. So you could fill 1, 2 electrons, and then when you're done with that, go to the 2s and fill 2 more. And if you have more electrons for that given element, you would keep going and keep following the arrows. And so you go there, there's nothing here, and so you go back up. And so after that, you would after the 2s, you would go back up here and fill the 2p. A p orbital will have, the p subshell will have 3 orbitals, and so we can fill 6 electrons here. And if you keep having electrons after that, then you would go down here and go to the 3s, and same thing, all these s have 2 electrons. If you keep going, that means you would go back here to the end of the arrow, come back up and fill the 3p. And then instead of filling the 3D, you would follow this arrow and you're going to go to 4s next. So this accounts for that overlap that we just saw. And so if you just follow this sequence, you'll be able to identify the electron configuration of any element. And I want to make a caveat here, a strong caveat here, is that this schematic works for a large number of the elements. However, there are a couple of well-known exceptions to this general filling sequence for specific elements. And so 95, 98% of the time this will work, but there are a couple exceptions, and we will talk about those as we go through the various examples and so forth. All right, so let's work an example here And so it says a think, pair, share activity, so ignore that. But this will be on your quiz for this week. And so what I want you to do is see if you can write the electron configurations for neon, and the atomic number is given, as well as magnesium. And so the atomic number, as you know, should tell you the number of electrons. So from there, see if you can use this schematic to write out the electron configurations for those two elements, and fill that out in the quiz, and then come back here and we will go over the results of that. So pause the video, go to the quiz, fill that out, and come back, and we'll look over the results. All right, so now let's look at that using the filling order for those. And so we're going to start with neon, which is atomic number 10. And so that means we have, because of the definition of atomic number, that means we have 10 electrons. So we start at the top here. So the 1s can have 2 electrons. So we're going to take 2 of those electrons and fill that 1s. And so the way we write this is 1s, and then we put a superscript s2, right? So we filled that subshell shell orbital, right? Because there's only one orbital there. Then we continue going, and the next one is the 2s, and then again has 2 electrons. And so since we still have 8 remaining electrons out of the 10, then we're going to fill this completely. And so we're going to have 2s2, written the same way, just the 2s. Then after that, we have the 2p, and then again, like I said, that has 3 orbitals, and that means that each of those orbitals has 2, so that means we have 6. So that means that we have 6. We have 6 remaining electrons, and that fills up. We're left with no electrons, and so this is what we term the electron configuration of neon. We're going to see something specific about neon in a bit, and so sometimes if you look at various references, you might see these square brackets around neon, and that's what it lists for the electron configuration. That's because it's a specific type of element that we'll talk about in a bit. And so if we keep going, and so we can use our work that we have here for neon, and with magnesium, we have 2 more electrons to fill. And so we would basically keep all that work, and then the next thing to fill after the 2p is the 3s. And so we fill that up because we have 2 more electrons. And again, you might see in some references that this term is used. So square brackets around neon, and then added to whatever else is left over. And so when I'm asking you to write an electron configuration for this class, I want to make sure that you use the complete. And so don't use these sort of shorthands that some references will use.